Now we're going to switch gears and talk about version control. Data analysis typically evolves over the course of a project. Usually, people keep a backlog of older versions by saving multiple similar versions of the same file. If you're really good and really consistent, this can work fine, but we're all human and our file names can devolve into chaos when the project gets tough. This is where having an automated version control system comes in handy. In general, these systems keep all the versions of a file in one place, typically under one file name. This helps you always know what the current version is, while still allowing you to revert to an older version. Many such systems will keep track of it for you so you don't have to remember a naming system or what you've changed. Let's look at some examples of version control in Google Docs, the Open Science Framework, and Git. I'll start with Google Docs. If you have a Google account, go ahead and open an empty document and follow along. So start by adding some text to your blank document. Okay, so now I have some text. I've made some changes to the document. So if you go into File and then Version History, you can see the version history here, and it'll show you the changes that I've made from one version to the next. If you want to, if you decide that this is an important version that you want to keep track of, you can actually name this version so that it's easy to remember to go back to it later. Okay, so you can go click the back button. Let's try adding some more text. Okay, so now if we go back to the version history again, you can see this option to name the current version here as well. We can see the additional changes that we've made since version 1. You may not want to save every single change that you make, but if you only want to see the named versions that you thought were important, you can toggle this option here. It'll show you the current version, but you can also only see the named versions. So this is kind of handy. The Open Science Framework is a free web app designed to support project management for researchers and promote reproducibility. I've taught a whole workshop about the OSF and how it supports collaborative research, and you can find those materials at the URL at the bottom of this slide. For today, I'm just going to demonstrate how the OSF supports version control using the demo project linked here. This is what an OSF project looks like. As you can see, there are many features which I won't get into here, but I want to show you how the OSF handles version control for text files. If you click on this VC demo file, you can see that it's a simple text file that you can edit right within the browser. I'm signed into the OSF and I have permissions to edit this file, but if you're following along, you should be able to see the revisions even though you can't edit. So you can go to the revisions button here on the right and see all of the past edits that I've made to this file, including for a previous workshop. If you wanted to see what a past version looks like, you can click on that version number. I'm going to go back to the current version of this file and make a few edits. So then I'll save it. So now you can see the version number changed to 12, and if I go back to the revisions, you can see that that was added to the list. In the OSF, if you wanted to revert to an older version, you would need to download the old version using one of these download buttons, and then re-upload it to the OSF using the same file name. Next, I'm going to demonstrate using Git, which is a more sophisticated version control system, and GitHub, which is an online repository where you can store and share files that are under version control with Git. You can use Git without GitHub, but they're often used together. Also, you can use Git and GitHub with a variety of file types, but I'm going to demonstrate how they can work with files in RStudio. There are a few extra steps to get started with Git in RStudio, which are covered in another workshop. But once you're set up, there will be an extra tab in the environment pane in the upper right section of RStudio. So if you click up here, you can see this new section. So now, if I make some changes to my script, I'm just going to add a comment. And then save that change. You'll see that this heightplot.r file now appears in our Git pane. So this is showing us that there's a change we've made that we have yet to commit. So if we wanted to commit or save that change locally, you can click on that checkbox for that file and then click on the commit button. And here it's going to show you exactly what changed in that file, and it's going to ask you for a commit message. So this is where you can describe what's changing with this version of the file. So now I can click commit and it will save that new version locally. But I'm also saving this project remotely in my GitHub account. So this is what it looks like on GitHub. So it's showing you some recent changes, it shows you what files are here. So now if I wanted to push that latest version to GitHub, I'm going to click on this push button. And it'll take a minute. Okay, so now if I refresh, I can see this last change, added a change for demonstration purposes. As an exercise, take a few minutes to consider these questions. Do you currently do version control? And if so, how? Think about the version control tools that you just learned about, and think about your research workflow. What tool would fit into your current workflow? And if none would, can you think of any alternatives? While you can theoretically use version control with any file type, it works best with text-based files. But most documents we use to write scientific papers are in binary formats like docx. How can you apply version control to manuscripts and reports? To do that, you can learn a text-based format like R Markdown. This document type lets you run code and write text interchangeably in the same document. When you render the text into a document, it can be saved in many binary formats like Word and PDF. And because it's text-based and version controllable, and runs your code right in the document, it makes your work very reproducible. If you go back to the example project in RStudio, you'll find an R Markdown file called height_bar_graph. This has a combination of text, which is written in Markdown, a lightweight markup language that adds formatting, as well as code in R. The code downloads our example data, loads it into R, and then creates a graph like the one we made earlier. It also runs the session info command to generate a report of what version of R and what packages I'm using. This R Markdown file is configured to create a report in HTML. To do this, I click the knit button, and you can see the rendered version with all of the formatting and the results of running the code. I'll end by showing you a handy checklist that you can use to determine how reproducible your research workflows are currently. Thanks for listening. If you need help, you can email me, visit our Data Management Services website, or use the online content shown on this slide to learn more.